Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is odd operations. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an integer n and you can perform two types of operation on it. The first is digit subtraction. That is, we will choose any digit present in the current decimal representation of n and subtract it from n. The second option operation is digit reordering. That is, we will rearrange the digits of n to form a new integer. Remember, leading zeros are not allowed. So for example, if we have 1067, that is the digits are 1067, we can rearrange it to make it something like 7106, but we cannot rearrange it to add an additional zero. Similarly, if we have 90, we cannot rearrange it to have 09 because this will be a leading zero and this will end up making it 9. Now, with these two operations, what we want to achieve is we want to find the minimum number of operations required to make n an odd number. And if this is not possible, we will print -1. Let's see the input format. So we have three test cases, and for each test case, on a single line, we will have a single integer that would be n. For the output, we just have to output the minimum number of operations required to make n odd. If it's not possible, we will print -1. As for the constraints, number of test cases will go from 1 to 10 raised to 5 and value of n will go from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the number given to us is 246. Now what we can do is we can simply subtract 6 from it. That is, we are performing the first operation. So if we perform the first operation, this becomes 240. Now let's say we perform another operation. We can delete 4 again. So now what this will become is, this will become 236. Why? Because once you subtracted 4 here, this becomes 236. These are two operations. These are both of type 1. Now for the third operation, we can simply rearrange it. Let's say rearrange to 263. Now this is an odd number. Therefore, it took us 3 steps to convert it into an odd number. For the second input, the n given to us is 10. Now we cannot perform the second operation because if we rearrange it, 0 will become leading and that will not be feasible. So for that reason, we will perform the first operation. Now subtracting 0 will not make any sense. So we will subtract 1. Doing so will convert it into 9. That is again an odd number. Therefore, it took us a single operation. For the third operation, n is 8. Now if you perform the first operation, this will simply become 0. And after 0, no matter how many times you perform the first operation, the number will still remain 0. Therefore, it's not possible to convert it using the first operation. And since there is a single digit, we cannot rearrange also. Therefore, it is not possible to convert it into an odd number. Therefore, the answer is -1. For the next sample input, we have 343. Since this is already odd, the answer is 0. Let's see how we can approach the solution. So the latest sample input that we saw is, if the number is already odd, then the answer is simply 0. Now what do we mean when we say a number is odd? We say that a number is odd if it ends with 1, 3, 5, 7 or 9. So if a number ends with any of these, we can say that the number is an odd number. So now what would happen if a sample number given to us or the input given to us has an odd integer? We can do what we have done in this case. Here, once we had 236, although the number is currently even, since it has an odd digit in it, we can simply rearrange it to bring it to the units place. If it is there, this will become an odd number in itself. So with this is the first thing. The first thing that we can notice, if the number is already odd, it is 0. Second thing is that if we have any odd digit, right? If we have a digit that is odd, we can simply perform the second operation and bring that digit to the unit place. In that manner, we will end up making it an odd number. Therefore, it will take us only single operation. Now that we are done with these two, it would mean that the number that we have has only even numbers in it. So for example, let's say 42. Next thing that we can try is we can try to subtract any number from it. So let's say in this case, if we subtract 2, this will become 40. If we subtract 4, this will become 38. Now if you notice, we are back to stage 2. We have a digit that is odd, so we will rearrange it and make it into an odd number. And we were able to do this in 2 steps. So that will be our answer. So if subtracting the number, right, makes it to a stage where it has an odd digit, we can then rearrange and make it to the answer 2. Now what about other numbers? Let's say it is not possible to do this in 2 steps, similar to what we have seen in this example, 246. In this example, you would notice that although the first subtraction that we made of 6 couldn't make it have an odd digit, but what we could get is that in the tens place, we got to a point where we subtract further, it will reduce. Since all the numbers are even, if we reduce the largest number at the unit place, it will come down a tens place. In that case, since this is all even, the previous tens state would be a odd number. So if we have 240, if we subtract anything, this will come into the range of 230s, and that will have a odd number with us. And once we have odd with us, we can simply perform the rearrangement and get an odd number. So if a number is greater than 10, then it is possible to get the answer in within 3 steps. So this is the next option that we can take. That is, first we will subtract the number to bring it to the tens place. Once it is at a tens place, we will subtract again. This will bring odd numbers to our state, and then we'll rearrange it, and within 3 steps we can make the number odd. Now what happens if the number that we have does not have tens place? If it is a single digit, then what can we do? Then if it is odd, the answer is 0. But if it is even, right? If we have even and it is less than 10, the answer is -1. We cannot do anything, as we have seen in the case of number 8 in our sample input. So with these 5 things in mind, we can get our answer. We will go over it again. If the number is already odd, the answer is 0. If we have any odd digit in our number, we can perform the second operation, rearrange it and make the number odd. If that is not possible, and we are at a point that we have all the even numbers in it, what we can try is, we can try to subtract the numbers, the digits from the number, and if we reach a state in such a way that it has an odd digit, then again we can rearrange it and our answer would be 2. So in 2 steps we could convert the number into an odd number. Now if even that is not possible, then what we can do is, we can bring the number to the tens place. So as you have seen in the example, if you have 243, we will try to make it to 40. Once we are at a tens place, any more subtraction will bring the tens place to its previous tens. So if it is 240, it will become 230s. If it is, let's say, 440 or 460, removing the tens will now become 450s. In that case, we will introduce a odd digit. Now again, once we have this, we can rearrange it and reach a odd number in 3 steps. But this is only possible if the number is greater than 10. If it is not greater than 10 and it is even, the answer is -1. With these cases, we will get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n. Now, as we have seen the 5 approaches, or 5 things that we need to check in our approach, we will start doing this. If the number is itself odd, the answer is 0. Then we have written a function to check if any digit is odd, right? So if any digit is odd, the answer is 1. We can simply rearrange it and make the number odd. If even that is not possible, from the number we'll start subtracting the digits. If that makes the number have any odd digit in it, then in 2 steps we can make the number odd. If even that is not possible, then we'll check if the number is greater than 10. If it is greater than 10, then what we can do is, we can make the number reach to tens, then subtract one more. This will introduce a odd digit in it. So with these 2 steps, now there's an odd digit in our number. So for the third step, we can simply rearrange and get an odd number. So with this, in 3 steps, we are able to make the number odd. Now if even this is not possible, then it would mean that we have a single digit number and it is even. Now in that case, it is not possible to convert it into odd with the given operations. Therefore, we print -1. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. We take the input of n. If it is already odd, we print 0. If there's any digit in it that is odd, we can rearrange it and make it odd. That takes us one operation. Therefore, if there is any odd digit in the number, we print 1. If that is also not possible, then we check if subtracting any digit makes the number introduce an odd digit in it. If that is the case, we will make the number odd in 2 steps. If even that is not possible, we check if the number is greater than 10. If it is greater than 10, it is always possible to subtract to bring it to a tens place, again subtract to introduce an odd digit in it, and then simply rearrange and make it an odd number. So for any number that is greater than 10, we can always bring it to an odd number in 3 steps. Now if even this is not possible, then it means that the number that we have is an even single digit number. For that, we print -1. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.